So today we're going to talk about the relay. We've seen this in a few videos before, at least the last video I talked about it. And it's going to create isolation electronically for our circuits that aren't triggered by, well, they're going to be triggered by the track. We can also trigger them by a pressure switch. What we're going to talk about today. Now the first thing when you need a relay right off the get-go, you need to know what the coil voltage is. That's this little white thing in there. That's the coil. Now these come in all different voltages to be triggered. 120 volts AC, they come like 24 volt AC, they come 12 volt DC. Obviously this one's 12 volt AC. I went with the 12 volt AC because our track basically runs anywhere from, well, 0 volts is stopped to about 18 volts AC. Most of the time I run the track about 10 to 14 volts. If I run it up to 17, 18, the train just comes off the track. So I don't even bother with that. Over here we have the contacts. We have a normally closed contact, a normally open contact, and we have the pins that come out the bottom. Those are rated, have a rating on them too. Let me see if I can see that. It's written on the top, upside down. So I don't know how clear I get that. But they're rated at 300 and I think 80 volts, 300 and anyway, well over 300 volts. And the DC is well over 220 volts, and they're both at 10 amps. So we'll be able to pull enough current to do anything we want to do with this track through this. It also comes with the contact block, so that's easy to sit in. I have the little terminal screws so we can wire everything together. When we set it up, we don't have to use jumper alligator jumpers like I'm using. This comes with this aluminum bracket. I have this one screwed down to the table. This doesn't move around. So we get these anchored. We could put this aluminum bracket anywhere. We could put it, vertical somewhere. We could put it under the table upside down if we wanted to. So that's kind of a nice feature. I did pick up one of these terminal blocks for wiring purposes, but it's not the type I wanted. These are the ones you have to have crimps on the end of your wiring. The ones I wanted were you stuck a wire in it, screwed them down, and you could hook several wires in them, screw them down to make my wiring a little bit cleaner, but that didn't happen. Before I go any further, I would appreciate any comments on this stuff, negative or positive. Just let me know what I'm doing. If there's interesting, if it's not interesting, let me know. Also, if you're doing this, you don't feel comfortable with doing electricity, please don't. I don't want to get anybody hurt. Just don't. So basically we'll go to the electronic print for this, or what this looks like. And the closest thing I can describe to this is, I just had it. Oh, I guess I'm not prepared very well. Is a three-way switch. It's about the closest thing this is going to be, except for when you push a three-way switch, it stays there. Think of this circuit as being, it goes up and automatically springs back. Is what the relay is going to do, except for being mechanically pushed, it's going to be done with an electromagnet. So this is the printout I have that I drew up. This would be our input. That was going to power up our electrical coil inside, our electrical magnet. Then we have our contacts out here. This would be the normally closed contact. They should be touching each other in this diagram. And our normally open contact. So at that point, this is the symbol for our normally closed contact, and that'll be our load, whether a light or whatever we're running out here. I just left that way. This is going to be our normally open contact, which will turn on the load. So when this relay is not energized, this second load ain't going to do anything. This one, when it's not energized, it's going to be on all the time, which I'll show over here. I have this light on, wired to the normally closed side, so it's on as long as the relay is energized. We're not having signal to this track. This one is off. Basically, that's open to the normally open contact. So when this track gets a signal to it, this will come on and this light will turn off. Now, instead of using a train for right now, we'll use it later. I'm going to use these scissors to arc out the track, simulating the train. You can see as soon as the signal comes in, the light goes out, the power comes on to the crossing guard. So I'm going to work on this a little bit more, but that's the basic idea. If I do this, I don't know how well you can see that. We can actually see the contacts move inside there, and that's what we're doing. So this can be a very powerful tool for us to use. We're going to get into using what's called a latching circuit, which in this situation is going to require 3 relays for what I'm doing. The first relay will going to be our trigger relay. We're going to use the contacts to trigger a second relay, which we're going to latch in. Then we're going to turn that latch off by a relay I set up way over there where that light was before. There's a relay sitting back, and I have a wire coming back. Again, my wiring's really rough because this will all be torn down again. So I'm going to go ahead and set up the next demonstration and show you what's going on. So I set up this next demonstration for the relay, and this is very, very crude. Like I said, I don't recommend mixing voltages on the same relay, so I'm going to use a separate relay. And I went ahead and did is I wired in a 120 volt circuit that's going to be make contact, and normally open contact is going to close when the signal trips, and it comes back and creates the 120 volt back to this plunger light for right now. This one's still in. This voltage is completely separate, completely isolated from the main track. So none of this 120 volts is going to be anywhere near this, just across the relay out to our example right now, light. So again, I'm going to use the scissors to arc out the track, and we'll see that, again, this light will go out, this will come on, and this light's going to come on this time. So what we're doing now, we control not even low voltage, but we control a higher voltage if we need to. Again, mixing voltages across the same relay, technically we could do that since there's two sets of contacts in it. I would not recommend it. Even getting these kind of in the same block, I wouldn't recommend. I'd recommend running this relay on a completely different rail away from this circuit, so you don't get confused and put 120 volts somewhere it shouldn't be. So that's one example of why we can use this circuit. And in this situation, I have the power to the transformer to the rail, powered by the first transformer, and I have the power for all this circuitry powered by the second transformer. So that's what I'm doing right now with this circuit. I'm going to go ahead and set up the latch circuit, which gets a little more complicated. So we'll see what that does.